Okay, so here, staying on with balancing equations, I've got a compound reacting with a compound, so I know that this is going to be double replacement. So iron's my cation, oxygen is my anion. So I like to switch my cations, which is going to give me potassium with oxygen, and the iron 3 with the permanganate. So I know that this was double replacement because I had those two compounds, and neither one, I didn't have an acid or a base or anything. It's just a regular double replacement. And so I then need to write my formulas. Iron being +3, oxygen being -2. Potassium is +1, as is permanganate -1, and so they just go. Then I've got iron with the permanganate now, which is going to have a -1 charge, and iron's +3, so that gives me FeMnO4, 3, and the potassium being +1 and the oxygen being -2. Again, it does not matter what order you write these things in terms of like potassium oxide first versus the iron permanganate first. It just doesn't matter, okay? What does matter is listing the cations before the anions. So that, that's just going to be up to you in terms of which compound you write first. Then we just have to balance it out. And so, let's see, I like to, get those polyatomics out of the way. 3 on this side, 1 here, so I'm going to apply that 3. That changes potassium to 3 and 2 on this side. So there's no way for that to actually match up. So I've got 2 here, 3 here. That least common denominator is going to be 6. So we're just going to switch that up, and now we end up with a 6 in front of the potassium permanganate, and so that means I need to put a 3 here. That makes oxygen 3, 3, good to go. Again, doing that change made the permanganate 6, and so I need to apply a 2 here. By adding that 2, I now have 2 ions on each side, and so that one is all set. For barium and chromic acid. Okay, so this is kind of a weird one because it doesn't look obvious as to what you're going to be doing here. Barium is a cation, okay, and then for chromic acid, you're going to have hydrogen, which is a cation, and the chromate, which is an anion. And so the barium is actually going to switch places with the hydrogen. And so now you're going to actually have hydrogen alone, and the barium chromate are going to be together now. So this really is a weird one, and it's kind of hard to see. So if you're ever unsure as to what you might need to be switching, sometimes it can help to have those formulas written first, because when you see the formulas for these, then it's also obvious that you've got that cation, anion thing happening. So whatever's easiest for you. So like I said, now we've got hydrogen by itself. Don't forget it's a diatomic. And barium is +2, chromate is -2. So there we go. 1 barium, 2 hydrogens, 1 chromate, and so this one was balanced already. Ooh. All right, so for number 94, we are dealing with a neutralization reaction. I know that this is neutralization because of the word hydroxide and acid. Okay, those are my clues that I've got neutralization. So right off the bat, boom, water is one of my products. Then we take the cation from our base, the calcium, and the anion from our acid. So hydroiodic tells me that I'm dealing with iodine, and so I'm going to have calcium iodine. Remember that it becomes iodide as when you're naming it. And again, this was neutralization. So we're ready to write some formulas. Calcium is +2, hydroxide is -1, hydrogen's +1, iodine is -1. My favorite formula, says hi. Then on our product side, we've got HOH. Again, I just like to write that as HOH to help me with my balancing. So for example, now I see I have 2 hydroxides on this side, but only 1 hydroxide on my product side. So I go ahead and stick that 2 in front. 2 iodines here, 1 on that side. I apply the 2 there. Now 2 hydrogens, and we're balanced. So for number 95, we've got an element reacting with a compound. And so nitrogen is an anion, aluminum is a cation, and bromine is an anion. Again, if it's helpful, go ahead and stick those charges in there. So because we're dealing with an anion switch, now I'm going to have bromine by itself, and aluminum is now with the nitrogen. So the nitrogen becomes nitride when we're naming. And again, this was a single replacement reaction. And I knew that because I had an element reacting with a compound. Nitrogen by itself is a diatomic, so it's N2. Aluminum being +3, bromine being -1. Bromine by itself is also a diatomic. And then aluminum is +3 and nitrogen is -3, so we end up with AlN. So you just kind of, again, just sort of pick where you want to start. I've got 2 nitrogens on this side, 1 over here, so I apply that 2. That made me have 2 aluminums on this side. I had 1 here, so then I do that too. 6 bromines now. Remember that those coefficients get applied to each element in that compound. 2 bromines over here, so I stick a 3 in front for my coefficient, and we're good to go. Number 96, okay, our last practice with balancing is a combustion reaction. Again, we can recognize that it's combustion because we are given a fuel and oxygen. So when we have that, we know right off the bat we're going to have carbon dioxide plus water. The pentane, I give you that formula. Oxygen is diatomic, CO2, and H2O. Again, reminders, we want to do hydrogen, then carbon, then oxygen. It's just going to make your life easier for balancing. And we don't use odd numbers in front of water. So hydrogen first. I've got 12 on the left, 2 on the right. So I'm going to put a 6 in front, which is great, easy to do, not an odd number, good to go. Then I look at my carbons. I have 5 on the reactant side, 1 on the product side. So I apply a 5. So my hydrogen and carbon are balanced, so I'm ready to move on to oxygen. I've got 10 from the carbon dioxide, 6 from the water, giving me a total of 16 oxygens. And so 16 oxygens over here, 2 over there. So I need to apply an 8. Okay, and that ends our balancing.